Alright, here we go. This is part 319, notes part 3. Sorry, the system's crashing a little bit on me. So it's a little bit shorter videos. But still more of the same problem. So our coordinates now -4, -1. So -4, 1, 2, 3, 4, down -1, right there. We then got to rotate this triangle 270 degrees clockwise, which is 90 degrees counterclockwise. So that means clockwise 270 degrees is this way. That's clockwise. So if something's starting right here, it's going to end up top. So if something goes to the right and down, it's going to go down and to the left. If it was a 90 degrees clockwise turn. But we got to do a 270 degrees clockwise turn. So that means something that's to the right is going to wind up going up. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 9, then 2 down. So we got to go up 1, 2, 3, 4, 5, 6, 7, 8, 9. Now down, when we rotate it around, that's actually going to be 2 to the right when we go through our rotation. So that's A prime. Now B is 1, 2, 3, 4, 5, 6 away. So it's 6 down from A, so it means we gotta go 6 to the right. 1, 2, 3, 4, 5, 6 to the right. Then B and C, they have a distance of 1, 2, 3, 4, 5. So it's 5 to the right. So if we're going 270 degrees clockwise, that means we're going to go 5 up from B prime. So 1, 2, 3, 4, 5. We connect them up. I could label them too. So we got A prime, B prime, and C prime. We go through our answers here. Is coordinates A and A prime the same? No, they're not the same. Neither is B, neither is C. Perimeter is the same and area is the same. The measure of angle B is the same. And the slope of AC, well, that's A prime, B prime, A prime, C prime is going in a positive slope. A and C is in a negative slope, so clearly they're different slopes. Same mark, they will not be the same. Alright, last one. Alright, so we got the coordinate -2, -2. So that means 2 to the left, 2 down. So this coordinate center of rotation falls on B. We have 270 degrees that we gotta rotate everything, and it's 270 degrees clockwise, so it's going in this direction, clockwise. So let's look at C here. If C is going to the right, if we rotate something 270 degrees, that's 3/4 of a turn. So it's gonna wind up right there, going upwards. So if we're going to the right, 1, 2, 3, 4, 5. That means we got to go up 5. 1, 2, 3, 4, 5. That would be my C prime. Now A is going up. If we're going to rotate that 270 degrees clockwise, so we start up here and we rotate it 270 degrees, we're going to wind up going left. So how much left? 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. And that's the location of my A prime. So we got A prime. B prime stays right where it is because it's being rotated right on itself. Connect them up. And there's our 270 degrees rotated triangle. Now, A prime and C prime, they're different locations. B prime is in the same location, so we got to mark that correctly here on our paper. So A prime is not the same, C prime is not the same, B prime is the same as B. Perimeter is the same, area is the same, measure of angle B is the same. The slopes, one's a positive slope, one's a negative slope, so clearly they're not the same. Anytime the perimeter and the area will be different is when we're working with dilation. So if you have the same type of setup of a problem and you dilate a figure, any dilation other than 1, meaning if it's 2, 3, 1.5, or less than 1, 0.3, 0.5, or 0.75 type of dilations, the perimeter and the area will change. But in all these problems that we've been doing with just rotations, the perimeter and the area stay the same. So that's why you always saw those stay the same. Alright. Nice classwork and homework. Hopefully this video helped you out. Alright, have yourself a good night.